Guys, thanks a lot for listening to this short video on how to implement hypothesis test in SPSS. In this tutorial, we're going to show you how to implement many hypothesis tests as well as interpretation using SPSS. We'll focus mainly on student tests, especially tests that allows you to compare mean. So that's one sample student test, independent sample student test, as well as one-way ANOVA in order to show you how to take some decision in practice. So we'll focus on interpretation, also show you how to make chi-square test using cross-table in SPSS. So let us start with student test and their interpretation. Independent sample student test is conceived in order to evaluate the difference in mean between two groups, two independent groups. So we have a variable in which, for example, we are going to see whether or not there are two groups have different mean in age. So for this tutorial, we'll just take an example of body mass index. So we have a database on body mass index recorded on students in secondary education, both male and female. So we're going to see this tutorial whether or not the body mass index differ from girl to boy. So we have our variable body mass index. So to run independent student test, you just need to go on analyze and compare mean. So you go on independent student test. You click on independent student test. You select the variable to test. So a variable that we are going to test here is BMI. BMI is body mass index. So we use the arrow to put it in the test variable section. So the second step is to select the grouping variable. So here our grouping variable is student gender. We are going to see whether or not there is a significant difference between body mass index among males and females in our sample. So we select the student gender variable and put it in grouping variable. So the third step is to define group. So we have seen in our group that we have two modalities for student variable. For student gender variable, which is one for female and two for male. So we will click on the define group button here. So we enter 1 for group 1 and 2 for group 2. Then we click on continue, and after that we click on OK, and the output will be printed here on your screen. So we have in the first table the group statistics. So we have numbers of observation: 1,425 female students and 867 male students. So the mean among the group in the group of male student is 21.34, and in the male population we have 19.74. So we have standard deviation of in each group as well as standard error mean. The second table here give information in independent sample test. What is really interesting here is the value of the student test, which is here, and the the degree of freedoms. We have also the significance of the test. The very important value here is a significance of the tail of the two-tailed test. So we have a p-value, the significance, which is the p-value here is equal to 0.000, which means that you can just reject the null hypothesis, which is the equality of mean between women and female. So we can not accept the null hypothesis, meaning that mean body mass index is difference between female and male population. And if we come back in our group statistic table, you can see that body mass index is more than the one among male students. So we can just think that female students have much higher body mass index than male students. How to run one sample student as well as the interpretation. One sample student test is a test in which one variable in which you are going to test if whether or not the mean of the sample is equal to a certain value. So for example, in this database we have many information including the age of the patient in our database, and we are going to test if whether or not the mean is equal to a certain value, for example 30. Make one sample student test in SPSS. Just go on analyze. When you are on analyze, go on compare mean, and there are many options here, and just choose one sample student t-test. So you click on one sample t-test. The first step is to select the variable that you are going to test, highlight this variable and use this arrow to put it into test variable section. So while you have put your variable in variable test variable section, you should choose the value of the mean that you are going to test for. So here I'm going to test if whether or not the mean of my sample is equal to 30 years old. So as I have put here the test value, the value 13, I can just click on OK. Result of my test here. So we have many information in the variable age, which is 443 person in the sample. We have the mean, which is mean of 35.22. We have standard deviation. So a very interesting table that we are going to use in order to analyze and find the conclusion of this test is the second table here, which is the t statistic of negative 15.62. The degree of freedom is 442, and here is the p-value in the third column of our table. Of the fourth column of our table, we have a p-value which is 0.000. Our p-value is less than 5%, meaning that we should reject the null hypothesis, which say that the mean of our sample is equal to 30-year-old. So we cannot accept the fact that our mean of our sample is 30-year-old. So let us choose for a test value just to 25. So you have seen that mean of our sample was close to 25-year-old. So we click on OK. In this second analysis, you can notice that our value is just equal to 0.459, which is significantly more than 5%, which means that we can just, in this case, accept the null hypothesis say that the mean is equal to 25. So in this case, we have accept the null hypothesis. I'm going to show you how to run ANOVA test in SPSS. ANOVA test is a statistical test mainly designed to search for mean difference between groups. So aim of the one-way ANOVA test is to search whether or not mean of the quantitative variable differ between groups. So in this tutorial case, we have two different variables. We have salaries and we have different categories. So we have agriculture, we have industry, and we have sales. These three sectors in which we are going to see whether or not the mean salary the salary differ between these or can be considered to be equal in these three groups. So to run ANOVA test in SPSS, you just need to go in Analyze, Compare Mean, and choose the last option test, which is one-way ANOVA. Then click on one-way ANOVA. So the first step is to select the dependent variable, which is the quantitative variable, put through this arrow in the dependent list. The second step is to select the category factors, which is category. Use this arrow put in the space related to factors. So we can go in option, choose to have descriptive statistics, fixed and random effects. So we will not select this option because 99% of tests are based on fixed and random effect models. So we select homogeneity of variance to see if whether or not variance differ between different groups. We also have Brown, Forsyth, and Welsh. So you can also select the mean plot and then click on continue and then click on OK. The first table that appears in our estimation result is the descriptive statistics. So we have here the salaries, and the first most important piece of information in this table are the mean and standard deviation of our variable. We have mean in agriculture, we have mean salary in industry, and as well as standard deviation of variable between different groups. So the test of homogeneity of variance is the test that search for the difference, if whether or not the variance are homogeneous between different. So the most important value we declared in this test of homogeneity of variance is the p-value, which here is equal to 0.000, meaning that we can consider that variance are not statistically equal. So variance are different among different groups, agriculture, industry, or services. So this 3.39 standard deviation in the service group are statistically different to the other standard deviation of in different other groups. So the third table that we have in this result is the ANOVA test, which is the test which gives the result about the difference between groups, between mean. So we have number of Fisher statistic here in the last but one column. So the Fisher statistic is 3.73 and the p-value is 0.02, which is less than 5%, meaning that we reject the null hypothesis that mean are equal between different groups. So we cannot accept the fact that mean salary is equal among groups. So in agriculture, industry, and service, mean considered is statistically different to the mean calculated in the other sectors. So we also have a robust test of equality of mean. So we have Welsh and Brown for sites. We have different degree of freedom as well as p-value that are less than 5% as previously. And in the plot, in the mean plot, we have the different value of the mean salary. This plot can materialize the difference between mean salary in different on how to implement chi-square test used when you are going to analyze the relationship between two quantitative variables. Instead, when we have a quantitative variable, we usually use correlation in order to analyze whether or not there is a link between two variables. But in case of quantitative variable, we may need to use a chi-square test in order to analyze the relationship between two variables. From chi-square independence test, just go on analyze. So let us just notice that is the database on survey on a company client, the general age category, reason of purchasing a specific good, payment method. We're going to analyze the dependence of some of variables. To run a chi-square test, just go on analyze. This statistic plus descriptive statistic. Click on cross table. So when you click on cross table, you have this interface that appears. So you can select row and column variable in order to analyze dependence or independence between variables. So don't mind if you put variable in row or column. So it doesn't matter whether you put variable in row or column. For example, to analyze whether or not gender and age category are dependent or independent variables, select for example gender and put it on rows, and after that select age category and put it on column section. To perform chi-square test, you go on statistic and select chi-square. So then you click on continue and then click on OK. So when you click on OK, you have this table results. So you have a case processing summary that the percentage of valid variables or variables were put in the analysis, which means that they were not seeing variable among gender and age categories. The cross tabulation between gender category and age category in each cell's concern, we have the count of the cell. So for example, men which were aged between 18 to 24 were 16, and men aged more than 64 were just 6 in our samples. So we have in the last table chi-square test. So the first line is chi-square, and in the second column we have 6.187 chi-square statistic test with 4 degrees of freedom, and the asymptotic significance here is a p-value which is 18.6%, which means that we can just accept the null hypothesis, which is gender and age category are independent variables. So we accept null hypothesis, which means that two variables are completely independent. So we cannot use for the age category, for example, in order to predetermine the gender of the client. So let us look at other variable. We go on descriptive statistic. We choose analyze descriptive statistic cross table. So we remove, for example, age category and choose the reason of payment. So we choose reason of payment. We have already selected chi-square, continue, and then click on OK. So you see that in this case we have a asymptotic significance which is 9.5%, which means that if we consider a 10% level, can just reject the null hypothesis, which is dependent between gender and the reason. So we cannot accept the independent between gender and reason. So the reason of payment can predetermine gender of a client. Can mean that there are some reasons which are more used by some gender categories. So that can be the explanation of the result of this test. If you consider a 10% level, let's look at second reason variable, reason 1, reason 2. So you can see that reason 2 are highly significant, which means that reason are price, commodity, service, and others. So we have a asymptotic significance which is significant even at 1% level, which means that we cannot reject the null hypothesis of independence. It means that there are a dependent relation between the reason and the gender. So there are probably some reasons that are more present in some group categories. So to make a little bit deeper in the interpretation, we can, for example, use odds ratio in order to analyze whether or not price influence positively or negatively. So that's it for this chi-square test, and hope we help you understand the chi-square test and the notion of dependence between qualitative variables.